All right. So, let me just grab my notes, get everything together. Let's get this started. So for those who are new to my site or haven't gotten the opportunity to meet me personally or talk to me on the phone or through email, my name is Justin Dickmeyer, and I'm the founder of engineeringtrainingexam.com, as well as our FE exam study program, Prepineer, at Prepineer.com. I'm a registered professional engineer in the state of California with a Bachelor of Science in Mechanical Engineering from San Diego State University. Now, today's guest educator is none other than the Director of Mentorship and Delight at Prepineer, and his name is Daniel Lynch. You've heard him just a minute ago now. During these cram sessions, we're going to be bringing you nothing short of the best talent. We're going to bring the best content. We're going to bring the best education, and you're not going to be able to find this anywhere else. And if we're lagging, I want you guys to tell us, because we can take it. All we want to do is provide value to you. And so we're just now launching this series. Tonight is the premiere cram session. And as always, we're going to be doing it all for free. So Daniel works with students like you all every single day. He helps students who want to pass the FE exam but find themselves either tight on time, struggling on knowing where to start, overwhelmed, dissatisfied with other resources that are out there. You just fill in the blank. One of Daniel's latest success stories that has come out of Prepineer was an older student who had failed the exam 5 times until she finally found our program, studied right, and passed it on her 6th try. Now, if you all know anything about the stats on the exam, let's just say they were against her the whole way. Daniel helped her establish a solid schedule and employ the strategies that actually work to get it done. He also just recently worked with a student who was 31 years out of college. He hadn't touched a textbook for ages, since graduating actually. And again, with the odds stacked against this student, Daniel helped him focus on what was important. He got his mind right, and that student went on to be successful. Now, at the end of the day, execution on this exam comes down to our ability to control our mind, shift through the knowledge that we've been taught, and use the tools that we are given to their fullest extent. So a few housekeeping notes before we get into it today. The theme of our March cram session series will be thermodynamics. Below, as you see right there, is listed the schedule and the topics of each workshop that will be held during this month. Now, these workshops are going to take place every single Tuesday, and it's important to remember that registration for each workshop will open up 4 days prior to the session being held. Now, the reason we do this is because of the high demand that we've already seen for these types of sessions. But I'll make sure that I send out an email when the registrations do open. So if you guys have Gmail, what we find is a lot of times our emails go to the promotions tab. If that's the case for you, go to the promotions tab and just drag over into your primary inbox one of my emails, and then everything will be sent specifically to your primary tab, and you'll be able to see it instantly. Now, I also want to remind you guys that registration for one workshop does not guarantee a seat in the next or all the workshops for that matter. So just make sure you guys register. That's all I want to make. That's the point I want to make right now, because a lot of people might think just registering for today will guarantee a seat in all future workshops. Now, before we get into it, I want to engage with you guys a little bit. I want to know a little bit about you. So how many of you actually out there have already attempted the FE exam at least once? hop on over to that GoToWebinar control panel, find that questions box, and give me a simple yes or no. Excellent. All right. Perfect. Perfect. So it looks like we have a nice mixture of those who have tried, who have experience, as well as those that are going at it for the first time, which is great. I think this workshop and all these cram sessions are going to be beneficial in some way for all of you guys. You know, you're going to take little nuggets here and there and actually be able to take real action on them. Now, for those who have taken it, what was the trip up in passing this exam? What actually kept you from passing it? Hop on over to that GoToWebinar control panel. Let me know. Give me a short synopsis. And I won't say your name or anything like that, so don't worry about it. You didn't study for it, you didn't have enough time, couldn't find momentum, you're nervous, test anxiety, didn't study right, didn't study properly, never had an action plan, too long out of school. Excellent. There's a ton of responses. Perfect. I gotta say that there's a ton of responses here, and I gotta say I'm not surprised by any of them. These are very, very common tripping points, and you're not alone. That's all I want you to know right now, is that you're not alone. So keep pushing. What has happened in the past is the past. Just start moving forward from here on out with a clean slate. Don't even think about it. And we'll help you as much as we possibly can with that mindset, because we feel that this is not just an exam testing your knowledge of the material, but it's also a mind game. You know, they want to test your ability to perform under pressure, because as licensed engineers, that's what we're doing. We're licensed to protect the public. So we have to be able to perform under these time constraints and the pressure. Now, for those who haven't taken the exam, what is the biggest obstacle holding you back? Again, hop on over to that GoToWebinar control panel. Let me know. Okay, time. You know, a lot of these are going to be crossovers. Time. There's many times here. Fear of failure. Very, very common issue. And you're going to hear in the next couple slides my story a little bit. Making time to do it. So it's another time. Motivation, no time. Time for studying, time with work. What is the right content to study in the time efficient manner? Excellent. Time is crazy here. Some people are still in school. Someone doesn't like standardized testing. Definitely get it. Excellent. Excellent. All right. So again, all these things do not surprise us. You know, I've been doing this for a very, very long time, and I got to say that I've had students that have come through EITE, or engineeringtrainingexam.com. You'll hear me call it EITE. As well as our preparation program, Prepineer, that have been in your exact shoes. So it's possible just to come in as you are. Don't worry, you have no flaw. You're not abnormal. Your situation is not different from 95% of the individuals going in to take this exam. So I kind of want to just set the tone for what's to come here. You know, give your guys some credit. Give yourself some credit. So, you know, when I first envisioned how the road would be for me as I started to pursue becoming a licensed professional engineer, I thought it would be a linear route, you know, a simple formula. Open a book, read some text, do some practice problems, take the exam, receive the good news, ask my employer for a raise, receive that raise, then become the next VP of my own company. So how'd that go? Well, when I began preparing for the FE exam, I had already graduated from college. And everything that I had learned during that time seemed to have disappeared from memory. When I opened up my review manual for the first time, I found real quickly that the state of my confidence, it was lacking. Excessive limiting beliefs began swirling in my head. Can I even do this? And bottom line, for the lack of better words, I just felt like I wasn't smart enough to make this happen. Overall, I felt that I lacked the knowledge I needed to pass. But this is the first thing I want you to hear, and I want you to hear me out on this. We all have a tendency to downplay our abilities and tell ourselves that we don't know enough. We all start here. Every single one of our peers, every single engineering hero you may have, started right where you are. I don't think I know enough. You think you don't know enough about engineering or math or electrical circuits or mechanics and materials. Or you can't figure out how to solve a second-order non-homogeneous differential equation. It feels like there are a ton of moving pieces, and you have to know everything about all of them before you can move forward with taking on the FE exam. Real successful engineers that have been through this journey know that's a lie. It's not that you don't need to know about statics or dynamics. You need to have some background in all of these subjects. Once you commit to taking this exam, these areas of knowledge begin to come back to you as you spend more time in review. But don't think you need to know everything or have been exposed to everything before you make the time to finally commit. It's not about what you can recall right now in this moment, but what you will be able to recall after successfully completing the journey and the great opportunities that will naturally come from it. But I continue to hear from aspiring engineers that they just don't think they can get it done. That's what I heard in a lot of your responses already. And again, it's not a personal flaw. I felt this way. You saw my story. 95% of the people I work with will come in with some similar story as well that equates back to this. Listen, we need to get our butts into motion. Knowing that this initial overwhelm is a default way of thinking that our mind just wants to lean towards. So what you need is a quick win. And that's what these cram sessions are all about. Establishing these quick wins for you, helping you gain momentum little by little until finally you're a freight train. Nothing can stop you. Whenever we start on a journey, regardless of what it is, we need to establish a quick win to help build our morale and give us a sense of achievement and enhanced momentum towards our ultimate goal. So in an effort to make a dent, and realize some progress today, today's cram session will be focused on the topic of thermodynamic properties. In its most basic form, the topic of thermodynamic properties falls under the subject of thermodynamics. Equations, symbols, tables, and information on the various topics covered under thermodynamics can be referenced on pages 86 through 101 of the NCEES Supplied Reference Handbook, version 9.3 for computer-based testing. So let's start off by defining what exactly a property is. A property is an attribute of a system to which a value can be assigned to describe the system. A defining characteristic of a property is that the value can be stated at a given time independently of its values at any other time. And it can be stated independently of the process by which the system arrived at its state. You may also see thermodynamic properties referred to as state functions. Now, no difference between these two terms. They are exactly the same thing. And as with many other things in engineering, each term is interchangeable. So that's the first note I want you all to remember. It can be a simple term that can create a huge trip up on the exam, and the NCES and the reference handbook oftentimes is inconsistent in keeping the same terms throughout the whole manual. So where can all these thermodynamic properties be found? The basic nomenclature, the units and other information of the state functions, or rather the thermodynamic properties, can be referenced on page 86 of the thermodynamics section. And that's under the heading of properties of single component systems. I've highlighted right there the location as well as the page number. Now, what are the major categories of thermodynamic properties? Properties of a medium can be divided into two major categories, also referred to as the state of a medium. These two major categories are, number one, the intensive properties, and these are properties independent. How many times can I say that? Of mass. Now, examples of intensive properties are pressure, density, and temperature. We also have extensive properties. Now, these are properties proportional with the mass of the system. Examples being volume, total enthalpy, total internal energy, mass. Now, what about specific properties? We've all heard about those in college, right? They're all over the tables everywhere. We'll be dealing a lot with what are known as specific properties, and these are properties determined by dividing the value of the extensive property by the mass of the system. Now, a specific property is commonly denoted by the lowercase version of the letter used to represent the extensive property. Now, recall from the previous slide, we just showed these extensive properties, which are volume, total enthalpy, total internal energy. Now we take those extensive properties, obviously not the mass, but we take all those and we divide them by the mass of the system to get the specific properties such as specific volume, enthalpy, entropy, internal energy, etc. Now, if you go to that reference handbook that we're given during the exam, there's going to be a very light definition of intensive, extensive, and specific properties. And this can be referenced under nomenclature on page 86. That's in the thermodynamics section. Now let's shift gears a little bit and talk about the units of property. Now, units are huge when it comes to performing well on any exam, especially the FE. So let's take a dive deeper into these properties, some of them, and the units that coincide with them. Let's start with mass. Now, mass is denoted with a lowercase m, and it's the measure of a substance quantity. It is expressed in the units of pound mass in kilograms. Now, actually, I want to throw out a side note here. Now, you see there's pound mass and kilograms. The FE exam uses both the United States Customary System, USCS, of units, and the International System of Units, the SI units. Now, this isn't necessarily related to thermodynamic properties, but it's a point of confusion that needs to be brought up and reiterated over and over so it doesn't trip us up come exam day. Now, the confusion revolves around the difference between pound mass and pound force. Now, I want to engage you guys. Now, how many of you out there kind of have a little bit of confusion around this subject? Hop on over to the GoToWebinar control panel. Do most of you, should I even jump into the difference? So there is. Kyle shook. I'm with you, bro, and I'm just going to say that. He says F English units. Thanks for censoring that, buddy. All right. You know what? I'm just going to jump into it. SI for life, bro. All right. So let's talk a little bit about this. Now, I know some of you have already said that this is probably a simple concept, but when you open up good old Google, our friend, right? Everything can be learned through Google anymore, but when you try to, find a solid definition of the difference between the two, you can leave yourself more confused than when you went in to the search. There's a bunch of crappy, ambiguous explanations and definitions that revolve around this particular confusion. Now, for those of you who are unaware, I know Kyle shook, you're aware, but the base units of the SI system are kilograms, meters, seconds, moles. Now, on the other hand, pound mass and pound force are from the USCS unit system. So, obviously that's not an all-inclusive definition of both systems of units, but now that the basics are over, from Newton's second law, we know that F is equal to ma, and that the result of that is a Newton. The force is the Newton. And that we get that when we multiply kilograms by meters per second squared, where, acceleration stands for, again, the acceleration A, and most commonly is 9.81 meters per second squared at the surface of the Earth. So that's the SI units. Now let's jump into the fun. USCS units. We take that same thing, F is equal to ma, and the result, F, is pound force. But we get that by multiplying a pound mass by acceleration, or foot per second squared, which is gravity, which is typically 32.2. So the mass of an object, whether it's kilograms or pound mass, does not change. However, the acceleration due to the gravity can change depending on the location of the object. So if it's on the surface of the Earth, it will be different if that same object was on the moon or 3,000 feet below the water, the surface of the water. So in a nutshell, the weight is measured in newtons or pound force, and mass is measured in kilograms or pound mass. So to get a force, we have to actually multiply pound mass, which we're going over here, by acceleration to get a force, a pound force. And that's the difference. Now, if we're given a pound force and we want to get the actual weight, we have to divide that by the acceleration. So that's kind of the difference. It's a cluster, and hopefully we don't have to deal with it on the exam. But that needs to be reiterated over and over and over and over again, because I remember actually having multiple questions with pound mass and pound force on the exam, and that just confused the heck out of me. So just remember that, okay? The force, pound force, is always divided by the acceleration if you want mass. And if you want a force, you have to multiply a mass or a weight by the acceleration. All right, so now that I've probably confused you even more, let's go ahead and get back to our regularly scheduled program here. Let's talk specific volume. Now, the specific volume is the volume occupied by a unit mass of a substance. It is expressed in cubic feet by pound mass or cubic meters by kilogram. Like we mentioned earlier, this is a specific property and is calculated as a total volume divided by the mass. So there's the standard formula for that. You take the full volume divided by mass, where V is the volume of the system in units of cubic feet and cubic meters. M is the mass of the system in units of pound mass or kilograms, and lowercase v is the specific volume of the system in units of cubic feet by pound mass or cubic meters by kilogram. All right, let's talk density. Now, the density is a mass divided by the volume, or the inverse of the specific volume. So those two equations are right there. So you got the mass divided by the volume, or the inverse of the specific volume. Again, M is the mass, big V is the volume, little v is the specific volume, and of course that rho is the density. Now this formula right here is actually not referenced within the thermodynamics section, even though it's important. You can actually find it in the fluid mechanics section on page 102. All right, let's look at a few properties that if you don't fully understand from the most conceptual basis, can make for a really, really bad day and in even worse results. And those two properties are temperature and pressure. Let's start with temperature. Temperature is denoted typically with the uppercase T, as you can see right there, and it is a thermodynamic property of a substance that depends on energy content. Now, a variance or a difference in temperature, denoted in delta T, is required for heat energy to flow, so it drives flow. We all know this from heat transfer, and obviously it takes place in thermo as well. The absolute temperature scale is the commonly used scale of temperature units in thermodynamic problems, and is given in units of Rankine and Kelvin. Now, we will commonly be given a temperature in degrees Fahrenheit or degrees Celsius and need to convert these units into Rankine or Kelvin using the unit conversions given to us in the NCES reference handbook. Now, all of these unit conversions formulas for temperature can be referenced in the table titled Temperature Conversions, and that's actually on page 1 of the reference handbook. I highlighted it right there on your screen. Now, absolute temperature scale in the USCS system of units is Rankine. So right there is the conversion scale. Will typically be given a temperature in Fahrenheit, and we'll have to convert that to Rankine. I've highlighted it for you. Again, that's on page 1. The absolute temperature scale in SI is the units of Kelvin. Again, I've highlighted that for you right there. We'll be given a temperature usually in degrees Celsius and have to convert that to Kelvin. And of course, we can always convert back and forth between Fahrenheit and Celsius using the given formulas that are highlighted there on your screen. Now, it needs to be brought up again and reinforced that it is extremely important to note the units of temperature called for in a specific formula you're using. Now, if you don't convert properly prior to carrying out your calculations, you're guaranteed to get it wrong. But hear me out on this. The NCEES will make you feel like you got it right. They will put that wrong answer right there smack dab in the middle of the options you're given for correct answers. Now, under timed conditions, you aren't going to think anything about it. You're going to just see the answer. You're going to see that it matches what you got on your calculator. You're going to click it. You're going to move it on. Now, another note of importance, and we all remember this hopefully from college, but if a formula is calling for the temperature difference, delta T, whether you're using USCS or SI units, there is no need to convert the temperatures to Rankine or Kelvin. The difference will be the same either way. So the difference in Kelvin will equal the difference in Celsius. The difference in Rankine will equal the difference in Fahrenheit. It's just a difference in temperatures. So this will be a time saver for anybody out there listening to me, because many students will go down the road of just converting it when they don't need to. And this is going to waste valuable seconds that can be used elsewhere. So just believe me in that. So let's talk pressure now. Pressure is denoted with an uppercase P. We all know this. And it's defined as the force per unit area normal to that force. Now, the general formula is given by P is equal to F over A, where P is obviously the pressure of the system. This is typically in PSI or pascals. The force is the volume of the system, the force is the force on the system in units of pound force or newtons. It's not the volume as stated there. And A is the area of the object in which the force is acting, given in either square inches or square meters or other unit of length. Now, the formula for pressure is referenced under the topic of fluid mechanics on page 102 of the NCEES Supplied Reference Handbook. So, know this, there are 3 measurements of pressure. You got atmospheric, which is also sometimes referred to as ambient. You got absolute, and you got gauge. Now, atmospheric or ambient is pressure exerted by the Earth's atmosphere at any given point. Or in other words, is the pressure at which the vapor pressure is equal to the pressure of its surroundings. Now, this is the pressure at which liquid boils. Now, there's some common constants to this. 101.4 kPa, 14.7 psi. We all kind of know those constants. 1.01 bar. Now, a few important conversions are stated right there on your screen. I pulled these from page 2 of the NCEES Reference Handbook. So you can kind of see how you can convert from one constant to the next, from atmospheres, bars, inches of mercury, H2O, pascals, PSI, etc. Again, that's on page 2 of your reference handbook. Now, absolute pressure is measured relative to the absolute zero pressure, the pressure that would occur at absolute vacuum. All calculations involving the gas law requires pressure and temperature to be in absolute units. So remember that. All calculations involving the gas law requires pressure and temperature to be in absolute units. Now, the difference between absolute and atmospheric pressure is what we call gauge pressure. Now, gauge pressure is either positive or negative is a vacuum. We use the following formula to relate absolute pressure, atmospheric pressure, and gauge pressure, as you can see right there. So absolute pressure is equal to the atmospheric pressure plus gauge pressure. And here's a nice little visual that shows how each of these pressures are related to one another from an absolute vacuum, or P absolute equal to 0. Now, all the formulas relating the various pressures can be referenced under the topic of fluid mechanics on page 102 of the NCEES Supplied Reference Handbook. So I want you guys to start picking up a little bit on some of these references. As you can see, again, the NCEES doesn't necessarily put all the required information in one particular location of the reference handbook. You've seen things on page 1, page 2. You've seen things in fluid mechanics. You see things in thermodynamics. It's going to be all over the place. So the important part of this cram session, the important part is to realize that we need to understand that reference handbook. We have to be able to control F, and find gauge pressure real quick. And that's another thing. If you look at gauge pressure, sometimes you go onto Google, you go into some of these books that we use in college. Some spell it with an AU, GE, gauge. But the reference handbook uses GA, GE. So if you go to find it, control find, and use AU, you're not going to find anything. All right, so let's reinforce some of the learnings we have covered through today's session with some practice problems. I'm going to actually ask for you all to engage during these practice problems. I need you to take action. Again, we've been together for almost 40 minutes here. I've been speaking pretty much to myself and a couple presentation screens here. So I need some love. I need you guys to hop on over to that GoToWebinar control panel and get ready to answer some of these questions. I'm going to put pressure on you. I need you to take action. Again, there was overcapacity signups for this particular workshop tonight. Some people got shut out. We reached capacity about 5 minutes before the presentation even started. So if you're just going to sit here and be a passive viewer, that's not what we need. We want you to take action because we want you to pass this exam. So let's check out this problem. The problem says a pressure gauge on the receiver of an air compressor gives a reading of 0.22 MPa, and that's gauge. What is the absolute pressure of the tank in kPa if the surrounding atmospheric pressure is 101 kPa? So take a look at that. We're going to go through this problem together. We're going to work it together. But I'm going to ask you right now to hop on over and tell me your guess. Don't take too long. We don't have too long to answer these problems during the exam. Excellent. Excellent. I'm seeing a ton of you great. All right, all right, all right. 5 more seconds. Get your answers in. Excellent. This is awesome. This is the action. This is exactly why we are doing this, guys. I'll continue to put together these workshops if you guys engage just like this. This is great. All right, let's get into the solution. So the first thing we need to do is establish the information that we are given in this problem. First, we have to recognize, number one, that the problem is given to us in SI units. Kyle, you're stoked, right? SI for life. So we're going to be working with pascals here. Now we are told that the pressure reading is in gauge pressure and that P gauge is equal to 0.22 MPa. We are given atmospheric pressure at 101 kPa. Now we're going to use that same formula that we just looked at in the previous slide that relates absolute pressure, atmospheric pressure, and gauge pressure. Again, this can be found, this table right here, this equation can be found on page 102. All right, guys. So I know some of you did this. From here, some of you are just going to throw the given values into the formula and just get at it, just rip up. But we can't just do that yet. If we did, we would come up with the wrong answer. And believe me again, the NCES, as well as Prepineer, we're going to plant this answer straight into your options so you choose it. Before we do anything, we must convert the gauge pressure from MPa to kPa. Remember, a kilopascal is 10 to the 3rd in pascals. A megapascal is 10 to the 6th. Now, if you need to refresh yourself on metric prefixes, you can reference that table on page 1 of the reference handbook. But get very familiar with them. So converting and solving, we get the following equation. 101 kPa, converting our MPa into kPa because that's what the problem asked for is in kPa. We're going to get an answer C of 321 kPa. So just look at that once again, how we did all that. And that's going to be your answer. Now, had we not converted the gauge reading to kPa, we really quickly could have seen that option A of 101.22 and just chose that. Because it was there, it was simple. We got that in our mind real quick. Yet it can be a catastrophe, it could be a catastrophe on our part. All right, so now look at the same problem. If the problem was written as a pressure gauge on the receiver of an air compressor gives a reading of 0.22 MPa gauge, what is the absolute pressure of the tank in kPa if the surroundings is at normal conditions? So what is going to be the difference? What would be the difference? What would your answer be in this situation? Hop on over that. Give me your answer. Once I see a number, once I see all of the answers, excellent. Yeah, so basically what is going to be the difference? Excellent. All right, so exactly. So a lot of you are asking the right questions. So what are normal conditions? What's typically normal conditions? Well, normal conditions are typically at 20 degrees Celsius, and that gives us air and a pressure of 101 kPa. That's typical. So if the NCES asks you in this situation, doesn't give you what normal conditions are, specifically in kPa, it's typically going to be 101 kPa. So there is no difference whatsoever. They're just trying to confuse you. So it will be the same. Absolutely, yeah. So a lot of you got this. It will be the same. All right. So for you guys angry at the USCS system of units, as I am, obviously, and Kyle, and many of you, if the problem was written in USCS system of units, what would the base units be? What would the base units be? Hop on over. Yeah, Javon, don't be mad, man. That's why we're doing these cram sessions. We got to realize this. So be mad for 1 second, but realize that now you know that answer. That's all we're here to do, is provide these little like tweaks that the NCES is just going to throw into the mix and try to just trip you up. We're trying to reveal these for you guys, all right? So what would the base units be if this was written in USCS? Excellent. Perfect. Well, it looks like most of you have this right. So USCS is obviously PSIA. PSI, you're going to see that. So you're right. Pounds per square inch is the base unit of the USCS system of units. So let's just hope we don't see those USCS too much, but chances are we're going to, because we spent 5 years in college working on SI units, and of course the NCS is going to make us do another unit system. Anyways, that's my rant. I can't go too deep into that. So we got about 12 more minutes, and I got more content. So what I think I'm going to do is skip nomenclature, and I'm actually going to email you all that little section with some of the most important nomenclature that you need to know on the exam. It's just be an additional resource. I want you guys to consume it. So it's not in emailable form at this moment. Give me a day or so to get that into that form and send it to you. What I'd rather do with the time remaining is actually hand it over to our guest educator, who has been silent now for 49 minutes, Daniel. And you there, buddy?
Hey, I'm still here, Justin. How you doing?
All right, buddy. Doing good, doing good. So what we're going to do now is kind of just cycle through some of these problems. And what I'm seeing is you guys are going to actually see the answers. So this is not going to be very helpful, unfortunately. I didn't blank out those solutions. So it's going to be a let's be honest exercise. As I flip through these slides, as Daniel's explaining them, don't look at the solution. Yeah, that's going to be definitely hard. It's like driving past a car accident and not looking, but do that. And try to answer these questions in the GoToWebinar control panel without looking at the solutions. It's going to be much more beneficial for you guys. So let's get her on. So go ahead, Daniel, take it on over, buddy.
So looking at the first one here, so this one actually does fall into the topic of nomenclature, which we said we would send out. But which thermodynamic property is the best measure of the molecular activity of a substance? So I'm sure everybody down there can say, hey, the answer is B, internal energy. But let's make it a little bit harder here. So what does everybody think the difference between internal energy and external energy? Can we come over to the sidebar here and tell us what you think your answer is here? Since we haven't learned it yet, just typically, let's start getting that thermodynamic mindset. What is the difference between internal and external energy?
Yeah, that's an excellent question, Daniel. Now, all these problems are going to be word problems, but they're going to be very, very common. You're going to see these very commonly on the exam, and that's why we're covering them. And Daniel, way to mix it up, buddy. Keep doing that. Challenge them. Make sure that they're working hard, and teach them a little something.
Yeah. So we see here we got Kyle saying internal energy is energy in the substance at a molecular level related to temperature. That's a great way of recapping what we just saw here for internal energy. That is definitely true. Let's see what else we got here. We got a lot of great answers. Phase changes. External energy is something like KE and PE, kinetic and potential energy. Sounds good. So internal energy, like we're saying here, is thermodynamics. Usually when we talk about thermodynamics, what's going on inside this substance, the chemical, whatever it may be. When we talk about external energy, we're going to be talking more about like statics, dynamics, vector mechanics. We're applying a force, we're applying things to a rigid body. That would be more external energy. So if I have a chemical and I were to, in theory, go with me here, push on the chemical, that would be the external energy that could potentially cause an internal energy change to occur, which is where we come into our favorite subject here, thermodynamics. So looks like we got a couple more answers going. Loving the response, guys. External energy is velocity, rotational. Kind of true. Dynamics would be a good example. Internal energy is energy that is a component. That could be somewhat interpreted of the component inside of the substance. So.
Excellent. Hey, Daniel, just since I'm controlling the slides, just tell me when you're ready to go to the next.
Let's go to that next one, Justin.
All right.
So a liquid boils when its vapor pressure is equal to 1 atmosphere pressure, the gauge pressure, the absolute pressure, the ambient pressure. So let's come on over here and let's see what everybody's answers. Maybe they could justify their answer a little bit more instead of just saying ambient pressure. So for those people who are putting they're putting A, what are they thinking here?
Yeah, for you, those of you that are saying 1 atmosphere pressure, just throw a little explanation out there for us so we can see where you're coming from.
Alright, so we've seen here. So it's like we're getting a lot of D's now. Ambient pressure is not always equal to 1 atm. That sounds like a pretty good answer. What do you say, Justin? Does that sound like a pretty good answer to you? It's not all, we can't always assume atmospheric conditions are ambient.
Yep, that's great. Great. Give a shout out to Paul Rousseau. That's a French last name, is it? Can't say my French is on point.
Let's go to the next question, Justin.
All right.
Which of the following is an extensive property? Temperature, weight, composition, pressure. So this one is one that I can guarantee be on the exam. You're going to get a question that says, which of the following is not an extensive property, or what is an intensive property? Some variation of that. Super fair game, super easy. You just got to remember that an extensive property is dependent on the amount of the material. So we got weight here. Yep, everybody's looking good. We got a C. We got someone saying composition. Weight. We got a lot of weights. It's definitely good. So what could be an example of another extensive property other than weight? Let's come on over here and give us another example here.
Yeah, let's see how many were up during that slide today.
So we got volume is the most common answer. Definitely correct. Someone was taking notes. Adrian Lovett, total enthalpy, density, mass. I saw someone put momentum. That could be considered an extensive property because it's dependent on mass. But that's more of a vector quantity, I would say, Justin, when you say more than a extensive property.
Right. I mean, yeah, it's definitely not going to be a thermodynamic question, that's for sure.
Yeah, so if you see momentum as one of your answer choices in thermodynamics, don't select that one. That's definitely something you'll see in dynamics. So we got mass. So we got the most. So the ones that we talked about earlier were volume, total enthalpy, total internal energy, and mass. So good job, guys. Let's go into that next question, Justin. Which thermodynamic property is the best measure of the molecular activity of a substance? So this goes up into some of that nomenclature that we didn't go over, guys, but still, fair game, we'll still send it out, but let's talk about some more about internal energy, which we were talking about earlier. So when you start talking about, for pressure, accounts for all the energy of the substances, including the external energy, like we were talking about earlier, which would be the pressures, things of that nature. This is just another really good example. When we get into thermodynamics, we'll be looking at what type of energy can be produced by a chemical reaction to cause a power plant to operate or cause a car to turn on. Those are the type of cycles we're going to be talking about later on in the course, and things that are super fair game on the exam, but we don't get you overwhelmed yet. But just as a little tidbit of what's ahead. So Justin, go on to that next slide. Which property of state is not an extensive property? Temperature, volume, number of molecules, and mass. So obviously everybody's seeing here temperature, we're all getting it right. And temperature is independent of mass. So like we did before, what's another example of a property that is non-extensive property? Pressure. So we got pressure, we got density, looking good. So the ones we talked about earlier were pressure, density, and temperature. So great job, guys.
So let's step up one more. So pressure and density, temperature, all intensive properties. So what makes something an intensive property? What makes something not an extensive property? Enoch, good job. Bill, great. John, Josh, Monson, Aaron Fisher, this is awesome. Excellent. Paul, great.
Great job, Jose.
All right, so since everybody, let's see.
Looks like we all got it.
Yeah, so intensive property, our properties independent of mass. Great work.
I think we already did this one, Justin. Go on to the next one. A substance whose properties are uniform throughout is referred to as what? A solid, an ideal substance, a pure substance, an isothermal substance. So this goes into some nomenclature again, guys, and we're trying to right here is this is a super straightforward question. There's no need to have spent hours working ranking cycle problems or anything that you're always fearful of thermodynamics. This is just simply knowing a definition. So we see here the correct answer is a pure substance. So pure substance is a substance whose properties are uniform throughout. So it looks like we're doing good over here. So let's throw it up a curveball here. So in thermodynamics, they love adding some vocab words in there. So isobaric, isothermal. Those are some other terms you could hear of an isothermal substance where the temperature is the same throughout. Isobaric. So I have a question for y'all. What do you think isometric means? That's a very fair game that you'll see throughout the exam. Is an an isometric process, an isometric substance. What is that? What do you think all that means? All right, we got a couple guesses here. So someone said, the correct answer is constant volume. Lucas, thank you. Great job. But this is what we're kind of talking about thermodynamics here. We're thinking about all these different properties, how they interact, things of that nature. So Justin, go on to the next slide. Pure water is boiling in an open pan at atmospheric pressure. Salt at a temperature equal to that of the boiling water is added. Immediately after the salt dissolves, which of the following will most likely occur? The boiling ceases, the temperature of the solution drops, the water ionizes, the entire mass becomes solid. All right, we're getting a lot of answers. A is the correct answer. The boiling ceases, but so why is the boiling cease, guys? Looks like we kind of didn't put the answer on this one to explain the exact science behind it. So, So Enoch, great answer, and also Aaron got it. Looks like, and and Paul got it as well. But the boiling point does increase, so that's why the salt can be boiling already, and then it will increase the boiling point, so it has to get more temperature, increase the temperature again to get to that point. I believe, Justin, this is the last question.
Yeah, that's right. So I'm surprised we got that under a little over an hour here, but I'm super amped that we got session number 1 of our new cramp session series. If I could, I just want to kind of survey you all that are still here. There's pretty much everybody, and I just want to know, how can we make this more valuable? Did we do it right? Is this the type of format that you like? Do you like the engagement? Do you like the practice problems? Do you like the review? If we can add something, what should it be? Hop on over to that GoToWebinar control panel. Let's just take 2 minutes. Just give us some of your input, because again, I said this at the very beginning. I could sit here till my eyes bleed to put together content for you. I have the content. I have the material. I understand the concepts. I can teach you all day, but I'm not about to go down the road of the boring professor, and I'm not going to go down the road of what other review courses are doing out there, because I want to shake things up. I want to make it more dynamic. I want to make it more engaging. I want you guys to learn. I want you to take action, and that's why I spend all the time that I spend doing what we do. And it inspires me that I get these emails every single day of people thanking me for helping them pass this exam. And that's what I want to do for every single one of you who are still on this call. I mean, everybody's on this call. So every one of you that have attended this call. So hop on over there. Let's do another 45 seconds. Just give us some feedback. Awesome. This is great, great feedback. I mean, what's really touching, and I'm not going to try to get sentimental here and cry. No, just joking. I'm not going to cry, but so many of you are just grateful. This is awesome. I mean, this is cool.
Hey, Justin, I wanted to jump in real quick, but guys, I'm seeing a lot of people asking questions saying, how are we supposed to know these random concepts, these questions? How are we supposed to know that? The FE examiner is going to try to trick you. They're going to try to expect you to know certain definitions, certain concepts, certain things that you may have seen in a thermodynamics class in college. we try to do our best to just try to pick out some of those concepts, but there's just so much fair game on the exam, so that's why it can be kind of overwhelming. But that's why we try to hit on these problems that are most likely going to be on the exam and give you the best breadth of knowledge so you know how to walk into the exam. And maybe in the off chance you see the exact same concept or something related. So now that you know about the salt, for example, you know it increases the boiling point, something of that nature. So next time you see it, you won't be fooled the same way you were on this simple question.
Man, Daniel, this is a ton of great feedback. So,
I'm trying to patch through it all.
I'm trying to scroll through
really
it all as fast.
I love Lindsay. She asked, "Hey, can we have a calculator hack for this?"
Heck
Just so
yeah,
you guys know,
of course.
you could technically use the calculator to use the equation solver to kind of set up any equation, and that way you don't have to do the algebra. But on this elementary level, I don't know. We could maybe try to come up with something, but you shouldn't have that many of a hard problem on the pressure gauge or something of that nature.
No, I think the biggest hack would be just converting from Kelvin temperatures real quick.
Well, actually, in the TI-36X Pro and the CASIO, they actually have a built-in equation converter in them. So let's say if you go into the exam and you blank, the conversion factors are slightly different, but it would get you in the right ballpark. So it would be able to, so you don't get stuck or feel like you're not doing the conversion right or something of that nature.
Yeah, totally. And it's most likely, so all these questions is what is most close to. You're not going to see like an answer that is a couple sig figs different, a couple decimals different. So yeah, those conversion factors work just fine. All right, well, I think we got a lot of great feedback. I mean, I'm going to sit here and read through every single one of these comments. It's going to take me a little while. And this is great. So, what we promised is that there's a nomenclature portion of this workshop that we kind of skipped over just for time's sake. Hey, Daniel, let's get that together into a, shareable form. Let's email it out to everybody that's on this call. And I'm going to repeat a couple of things. Number one, if you use Gmail or use really anything, but Gmail specifically, if my emails are going to your promotions tab, go there and just drag one over to the primary tab, and that's going to fix the problems so that you're able to see the invites, the resources that we send out much quicker. Because once again, these workshops are going to start filling up even quicker, guaranteed that. So the next one is going to be, as you see there, on phase diagrams. We're going to hold that next Tuesday. That's March 8th. It's going to be at the same time, 7 p.m. Central. So that invite's going to go out on Saturday. And again, the reason I do that is just because of the demand. Actually, I want those that are action takers to see it first. And a lot of people don't check their emails on Saturday. So it's kind of my filter to make sure we only get those action takers. So Saturday is going to go out. I'll send out a reminder, obviously, just like I did this week on Mondays and Tuesdays. So make sure you check your email. I'm going to ask, and I'm also going to probably send out an invite. Look for us on Facebook, Engineer in Training Exam. If you want to follow us there, I'll actually post the invite there as well, so you're able to see it through Facebook. So that's all I got for tonight. Daniel, let's make sure we get back to every single one of these individuals. Thank them for their feedback. Thank them for attending. Give them the additional resources. And go from there. So that's all I got. Do you have anything, Daniel?
Yeah, thank you everybody for coming out and getting a lot of really great feedback and everything. So be on the lookout for an email from me. My email is daniel@prepineer.com. That's the email everything will be coming from. So look forward to sending everybody that nomenclature review, and here to answer any questions you guys may have on the exam or any content, whether it may be on the exam, how to prepare for the exam, how to study for the exam. Feel free to reach out to me anytime. I'm here to help. And hopefully everyone has a great night.
Okay, that reminds me of one thing. What I'm going to do is if you go over to the go to webinar control panel. See if that went. All right. Well, did that just go? Well, if anybody has questions, because I see some of you saying, can I confirm my email? Can I confirm my email to make sure I get this nomenclature handout, the additional resources, things like that. You can confirm by just send an email to Daniel. That's D-A-N-E, sorry, D-A-N-I-E-L at Prepineer, and that's spelled right there actually on your screen, Prepineer.com. And I tried to post that in the conversation, but I'm not seeing it go through. So if you guys see that in the questions box, you can copy and paste it, but that's Daniel, spelled normal, D-A-N-E-I-E-L, at Prepineer.com. Just send him an email confirming your email address, and we'll make sure you get all the resources that we have, all right? So for tonight, I want to thank you all again for attending. I want to thank you for your valuable feedback. And again, one last thing, just again, act fast when those invites come out. I want to make sure every single one of you that came on tonight gets on next week, because you guys were actually one of the most engaged audience I've ever had on a workshop. And this is beautiful because you guys are taking action, and that's what I want on these workshops. I don't want no passive individuals. So see that. It's coming out Saturday, and we'll get her done. So did you have something, Dan?
Yeah, I was just going to say, I just shared the Facebook link, so people were saying they couldn't find it. So we're going to start posting everything on here as we go along. And just go ahead and keep connected with us and let you know and post any questions you may have on the FE exam, and we'll do our best to get back to you.
So you shared the Prepineer. Let's give them the engineeringtrainingexam.com as well. If you can. Thanks, guys, for your patience. We are 13 minutes over the hour. It won't typically
Thanks,
be...
Zach, for the kind words. Hearn, Ed, Gita, it's great seeing you guys here. Javier, Lindsay, George, Christina, thank you guys. Until next time.
Hey, Daniel, do you have that engineeringtrainingexam.com Facebook link? Hey, Daniel. You still on, bud?
I'm still here.
Hey, put up that engineeringtrainingexam.com link to Facebook as well.
Oh, yeah.
And we can also share it when we send out the resources. Make sure everybody has as many contact points as possible. Want to make sure all these action takers are on ours. Excellent. All right, guys. Well, thanks again. Have a beautiful night, and be watching out for our emails. We'll be talking soon. Take care. Bye-bye.